Hi all, welcome to Sidza.com. Now let us discuss about the collision theory. When a chemical reaction occurs, suppose the reaction is there between A2 and a B2 molecule to produce AB. According to the collision theory, the reactants get converted into products only when the reactant molecules collide with one another. So the important requirement for the product to be formed from the reactants is that reactants should get collided, right? So the collision is an important thing, right? Reactant molecules must collide with one another and only then they will form the product. If there is no collision, product cannot be formed. So when A2 molecule collides with a B2 molecule, the product can be formed. But since every collision does not form a product, sometimes the molecules collide and they may not form the product. And sometimes the reactant molecules collide and they will form the product. So that means a collision may be effective or ineffective, right? So a collision may be effective or it may be ineffective. Means when a collision occurs and you get a product, it's called as a collision. This is called as an effective collision. So from an effective collision, you get a product. And from ineffective collisions, no products are formed, right? No product is formed there. The question here is, what are the conditions for the collision to be effective, right? What are the conditions under which the reactant molecules collide and they form the product? According to collision theory, for a collision to be successful, that means for a collision to be effective, it has to satisfy two conditions. Number one is that reactant molecules, the colliding molecules, must possess certain minimum amount of energy, which is called as a threshold energy. And when molecules having this threshold energy collide, they can form the product. If the molecules have energy less than this threshold energy, less than this minimum amount of energy, then product cannot be formed and the collision will be ineffective. So the first condition is that the colliding molecules should have sufficient energy, right? And that sufficient amount of energy is called as a threshold energy. Second thing is orientation. That means when molecules collide with one another, they should collide at a proper orientation, right? So the second factor is steric factor. Number one is energy factor. The number two is steric factor. When the reactant molecules, when the colliding molecules satisfy both these conditions, then the product will be formed and we can say the collision is effective. Here this is the energy of the reactants and this is the energy of the products. According to the collision theory, reactants they should have first the energy, this threshold energy, right? And only then they will form the product. So that means reactants do not directly convert into product. They must attain a threshold energy and after that they form the product, right? So actually reactants have to cross over this energy barrier, right? Only then the product will be formed. And now suppose this is the energy of the reactants. Suppose for the understanding purpose, I'll put some hypothetical values here. Okay. Say for example, reactant molecules have a 150 kilojoules of energy, right? 150 kilojoule per mole is the energy of the reactants, and for the reactants to form product, they should have the minimum amount of, say for example, 400 kilojoules, right, per mole. So this energy difference here that you see between the threshold energy and the energy of the reactants is called as an activation energy. The extra energy needed by the reactants to reach the threshold point, right, is called as an activation energy. Okay, so that means when the reactant molecules gain this activation energy, and how much will be this activation energy? It will be 400 minus 150, right? It's 400 minus 150. That is the difference actually, that you see between these two, right? The threshold value and the average energy of the reactant molecules. Okay, so it will be the 250 kilojoules, right, per mole. So that means when the reactant molecules gain this activation energy of 250 kilojoules, only then they will form the product. Now, what if the reaction is reversible? In that case, when the products get converted into reactants, for the backward reaction, the activation energy will be this much, right? This is the activation energy A for the backward reaction, right? This is for the backward reaction. And this will be the activation energy for the forward reaction, right? Because now, when the products get converted into reactants, the threshold energy minus the energy of these products here, that is the activation energy for the backward reaction. So this is in case when you have a reversible reactions. And reactants convert into products and the products get converted back into the reactants. When we look at the the energy distribution curve for the different types of molecules in the reactants, suppose this is the graph showing different fractions of the molecules having different kinds of energies here. And let's say suppose this is the threshold energy, right? This is the threshold energy. That means the molecules having this much of energy, the energy equal to threshold energy or more than that, only those molecules when they collide they will form the product. So if you look at this graph, the area under this graph is like this. So these are the molecules, the graph that you see here, this is the area which represents the number of molecules which possess the energy equal to threshold energy or more than that. That means only this is the number of molecules that can form the product, because they have the energy equal to or more than the threshold energy. Molecules possessing the energy less than this threshold value, this is the area here, right? The white area that you see here, this is the area which represents the number of molecules having energy less than threshold energy. That means these molecules cannot form the product. Okay, so at any particular temperature, different molecules have different energies. Okay, and the molecules possessing the threshold energy, right, or more than that can form the product. Only those molecules can form the product. Now, when you increase the temperature, what happens that the more molecules possess this threshold energy and the rate of reaction becomes faster. Effect of a temperature we will discuss in the next video, how the rate of reaction increases when you increase the temperature. So the first point here is, according to collision theory, that the first condition for the reactant molecules to form the product is that they should have energy equal to threshold energy. That minimum amount of energy is called as the threshold energy. Second factor that the reactant molecules must satisfy is that they should have a proper orientation. Correct? Proper orientation. So sometimes when the reactant molecules collide, they may have the sufficient amount of energy, they may have the threshold energy, but still they will not be able to form the product because the reactant molecules may not possess that proper orientation at the time of collision. So then even though the reactant molecules have the energy equal to threshold energy, still the possibility is that it may not form the product because of the lack of orientation. So the second factor is that the reactants should have the proper orientation to form the product. So now in our next section, next part of this video, we will discuss the effect of the temperature and the catalyst on the rate of reaction as per this collision theory. Hope you got the concept. Thanks for watching the video. Bye for now.